All right, so slightly more advanced probability question, right? Because we have compound probability, right? Not just one event happening, but two events happening, right? We also have to know about prime numbers, so there are a couple layers of complexity to this, right? So when you have compound probability, you should always look for whether it's with or without replacement in the question. They always have to tell you whether they're going to replace whatever they're picking out or not, right? So we have without replacement, meaning that if we pull it out, we're not going to put it back in, and that means that it's going to affect the probability of what happens for like the second pick, right? So we have 6 balls from 0 to 5, right? So, and we want to know the probability that both numbers drawn will be prime, right? So we have one with a 0, a 1, a 2, a 3, a 4, and a 5 for a total of 6 balls. Sorry, let me put the 5 over here, right? So first things first, right? 0, this is not prime, right? Number 1 is not prime. So big mistakes I see with prime numbers in general on these tests are thinking that 1 is prime, 1 is not prime. Number 2 is prime. It's the only even prime number, right? 3 is prime, right? 5 is prime, and 4, right? 2 is the only even prime, so 4 is not going to be prime, right? So we have more prime numbers, obviously, in the smaller numbers of the, the smaller numbers than we would as we go, higher up with past 5 or whatever. So the probability that the first ball is going to be prime is going to be, we have this one, we have 1, 2, 3 that are prime. So the probability the first pick is going to be prime is going to be half, right? 3 over 6, right? Now the probability the second one is going to be prime. Remember, we are not replacing it. So now we have 5 left in here. So my denominator is 5. And if we pick the first one and it was prime, it means this one, if we didn't replace it, cannot be, like this one would have to be 2, right? So we want to go down each one. So we would have 2 prime numbers left in there and only 5 numbers overall. And then what we do is we multiply them, right? So the probability one thing's going to happen and then another means multiplication, right? So that's going to be 3 times 2 is 6, 6 times 5 is 30, and 6 over 30 equals 1/5. So the probability that they're both going to be prime would be 1/5.